Okay, so for our first example, we want to solve the absolute value inequality. We've got 2 times the absolute value of x minus 1 plus 8 is greater than or equal to 12. Now, solving an absolute value inequality is very similar to solving an absolute value equation. We really don't get the big difference until we start doing our answer. But our steps that we learned for solving an absolute value equation actually kind of follow through with this as well. We do need to isolate our absolute value first. We need to get it in what we call that, remember we called that standard form. So the first thing we wanted to get rid of is this plus 8. Remember, we always want to move the addition subtraction first and then do our 2. So here we're going to subtract 8 from both sides. So 2 times the absolute value of x minus 1 is greater than or equal to 4. Now that we've got that, we can divide by 2. And we get the absolute value of x minus 1 is greater than or equal to 2. Now, what I want you to do is I want you to stop for a second before we go any further. I want to talk about this symbol. Now, we just talked about the 4 different cases, less than or equal to, greater than or equal to, less than or greater than, to talk about how those graphs looked. And I gave you an example of each one. So if you think back to what we were just doing in the previous one, when we had the greater than or equal to symbol, this was this is where we shaded outside. Okay, basically our graph is going to look something like this, where we're going to have a closed bracket. Again, a reason it's going to be a closed bracket is because we have this equality here, and I'm going to shade to the left of what I call my low number, and then I'm going to shade to the right of my high number. And this is just going to make it a whole lot easier. If you'll stop and look at your inequality and look and see which pattern it fits, it will help you when we get to the portion where we're actually writing out our interval and our algebraic notation, because we're going to do that on every problem that we do for this video. Now, just like when we did our absolute value equations, I still need to acknowledge that I have both a negative and a positive side of this problem. And I'm actually going to completely ignore the fact that this is an inequality right now, and I'm just going to change this to an equal sign, and it's going to look extremely similar to what we just finished doing in the previous section with absolute values. So we're going to have x minus 1 is equal to a negative 2. Remember, not changing anything about my absolute value, just changing my constant. And then I'm going to have x minus 1 equals a positive 2. So solving each one of these, I'm going to add 1 here. And for our negative side, or our low value, x is going to equal a negative 1. And then here we're going to add 1 to both sides. And for our high value, x is going to equal 3. Now, I'm actually going to take this to the graph next, and then from the graph we're going to write the interval and algebraic notation. I find that's the easiest way to work these problems as far as making sure that I've written the format correctly. So just drawing a really quick number line. It doesn't have to be beautiful, it just needs to have the values. It doesn't even have to be labeled real pretty. I have negative 1 here, here's 0, here's positive 3. Now, if you remember, I stopped up here to talk about how this was going to shade, and I said it was going to shade to the outsides, so to the left of my low number, to the right of my high number. So now I know, looking at my graph and remembering that this is a greater than, it's going to shade to the left of my low, which was negative 1, so it's going to go out from negative 1 to negative infinity. And then on the positive side, it's going to go from 3 out to positive infinity. I also know, because I'm dealing with a greater than symbol, that both of these guys are going to be brackets. So now I know what my graph looks like, and this is going to help me write my interval notation. So when I write my interval notation, I'm going to have to use that union thing we talked about in the previous examples because I do have two distinct areas of my graph. So when we write this guy as interval notation, he's going to go from negative infinity up to -1 with a bracket. And on our other side, we're going to start at 3 and go to positive infinity. And again, we have a bracket at 3, a parentheses at infinity. And then for our algebraic notation, again, because we have two shaded areas on our graph, we know we're going to have two algebraic notations. We're going to connect those with the word or. So on this part, we want our value of x to be smaller or less than. So this is going to be x is less than or equal to -1. And then on our other side of our graph, we're wanting x to be bigger or greater than 3. So on the other side, we have x is greater than or equal to 3. Okay, so for our next example, we're going to solve the absolute value of 2 times x plus 4 minus 4 is less than 0. So again, before we do anything else to this absolute value, we need to isolate the absolute value or get the absolute value by itself. Again, the first thing we need to move is this -4. So we're going to add 4 to both sides. Once we add that 4, we're going to have 2 times the absolute value of x plus 4 is now less than 4. These guys going away up here. Again, we want to get rid of this +2 that's multiplied, so we're going to divide by 2 on both sides of our equation. So we're going to have the absolute value of x plus 4 is less than 2. Again, I want to stop for a second and just kind of look at what symbol I've got going on here. And I do have a less than symbol. That was actually the first of those 4 possibilities we went over in when we first started talking about absolute value inequalities. If you'll remember, this is the problem where we actually shaded between the two numbers. Okay. Our graph where we shaded here in the middle. Now, because we're looking at this particular problem that says less than, that means on either side of this guy we're going to have open parentheses. This is going to be my low value. This is going to be my high value. Again, if you'll stop and do this right after you've isolated that absolute value, it makes it so much easier to do the graphing and the shading and the interval notation and the algebraic notation. Just it helps so much. So now remember, we still need to figure out our two answers, our negative and our positive, or our low and our high values that we need to find. So we have x plus 4 is equal to a -2. Again, remember, not changing anything about the absolute value, just changing the 2 to a negative. And then on our positive, we have x plus 4 equal to 2. And we're going to solve each one of these guys for x. So right here, we're going to subtract 4 from both sides. And we get that our low value is going to be x equal to -6. Here we're going to subtract 4 from both sides as well. And we're going to get our high value as being x equal to -2. Now remember, it doesn't necessarily have to be a negative answer and a positive answer, just one is larger than the other one. So now, again, I just like shading and graphing better first and then writing my interval notation from that. So here's my graph. Here's 0. I've got -2 is right here. -6 is down here, and I want to shade again because I'm looking at a problem that is less than. I want to shade between -6 and -2. And then because it is less than, that means at -6 I have a parentheses, and at -2 I also have a parentheses. My interval notation is going to be one interval. It's going to start at -6 with a parentheses and end at -2 also with a parentheses. And when we do our algebraic statement, it is also going to be one set, and we're going to say it goes from -6 is less than x is less than -2. So when you're thinking about this and you're thinking about shading between or shading on the outside, remember if it's less than, you're going to shade between the two numbers, and if it's greater than, you're going to shade on the outside. That means when you're doing a less than problem, you're going to have one interval notation, you're going to have one algebraic notation, that's that compound inequality. And then when you're doing a greater than, you're going to shade on the outsides, so that's going to give you two interval notations, and that's going to give you two algebraic notations. It's really going to help if you'll remember those as you're working through these problems.